Okay, so we're going to talk about percentiles, measures of position again, and quartiles. And I want you guys to try this example on your own. This will give you an opportunity to read a little bit different stem and leaf, and also the opportunity to practice with the indicator function and finding percentiles as well as quartiles, switching back and forth between languages. So what I want you to do is I want you to use the indicator function to find the 10th percentile, the first quartile, the 50th percentile, and the third quartile. I would also like you to give me a secondary name for the 50th percentile. And if you can, challenge yourself and go ahead and give a third name for the 50th percentile. So why don't you go ahead and pause the video right now and try to work through these on your own, and then start the video again and see if you got it right. All right, now that you have hopefully worked through these, let's go ahead and work through them and you can see if you are correct in your process. So the first thing to find the 10th percentile I'm going to do is I'm going to find the indicator of where the 10th position of the in the data would be located. So 10%, so that's 0.1 times the number of data points. And I did give you a little help here. I said this is the decibels of 50 ordinary household items, so you know that n is equal to 50. So this is going to give me 5. Well, when it's a whole number, remember that I have to use the 5th and the 6th positioned data point. So I'm going to go ahead and go over here and say, okay, 5th and 6th. So that's 1, 2, 3, 4, and 5. So there's my 5th one, and there's my 6th one. So these represent times 1, so this is 55, and then this is times a 10th. So this is 0.8 and 0.9, so 55.8, 55.9. So I have 55.8 plus 55.9, and that will be divided by 2 in order to give me my decibel rating. And so this will give me 55.85. Now you don't want to round it off or anything, just leave it alone. That's the rating that we have. So that is the 10th percentile. Now my next one, my first quartile, that is P25. So that is the L25, so I need a quarter of the 50. So a quarter times 50, 4 does not go in here evenly, so I'm going to have a fraction 1. So 4 will go into 5 one time with 1 left over, and 4 will go into 10 2 times with 2 left over, so it's 12.5 or 12.5, whichever you want. So this is going to go up to the 13th position. Remember, it's not really rounding, it's always going up. And so I will be looking for the 13th positioned data point in order to find my 25th percentile. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 57.2 is my value. 57.2. And these things are decibels, and I didn't have room up there, but I'll write it here just to remind you, you really should be always, always, always writing your units. I am particular about that if you are taking one of my classes. I want to see that you're thinking about what these numbers mean, and they're just not numbers only. All right, now to do my 50th percentile, L50, what I'm looking for is half the data. So half of 50, right, 50%, half is 25. Again, this is a whole number. When it's a whole number, I don't just stop there. I say, oh, I've got to have the 25th and the 26th data point averaged. So I'm going to go and I'm going to look for the 25th and 26th. The 13th one was 57.2. So there's 13. 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and 26. So 60.8 and 61. So 60.8 plus 61 and they get averaged. Now this one's not as easy to average because they're not right next to each other. So I have to actually do a computation here in order to find this value, and I find that it's 60.9. So 60.9, and again, really should be writing that it's decibels. Now I challenged you with a couple of other things with this one. What are some other names that we may see for the 50th percentile? Well, that would also be the second quartile, and it would also be the median, x tilde. Alrighty, going on to our last one. For the L75, you could certainly do this, but what you're going to find is that as you get larger and larger data sets, counting all the way through the data is much harder than just taking the L25 from the top. So I'm going to go back to my L25, and that was 13. So I'm going to do the 13th from the top. So I'll go over to my data set and I'll count from the 13th from the top. Now this problem has a potential outlier out here, way out here. There's a 77.1. So I don't want to forget to include that. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And that would be 64.6. So my Q3 here is 60, is it 64? Yes, 64.6. And those would be in decibels as well. So those are the quartiles and the percentiles that I had asked you to find for these particular data points. Hopefully you did a pretty good job of those and were able to find them with ease. And you're getting adjusted to using this indicator function for indicating where the position in the data is. Now the next thing we're going to talk about is something called the interquartile range. Now the interquartile range is related to our first and our third quartiles. That's why it's called an interquartile range, right? The first and the third quartiles. We're going to find out what is between these interquartile range. Now the interquartile range, that should in symmetric data encompass about 75% of the data. Now there's a little bit more to that. We can relate that back to that kind of the bulk of the data in terms of the symmetric data, and we could make it a little bit more into the 67%, and we can talk about the bulk of the data and why we're doing what we're going to do to find this these fences to tell us where we may have potential outliers. But rather than going through that, I just want to call to your attention that first of all we're going to find out where is our bulk of our data, and then we're going to say the bulk of the data. Beyond that, we're not going to be finding a whole lot of extra data, and if we go about 1.5 times beyond that range, what we're going to be having is potentials for outliers. So finding the interquartile range can help us then to pinpoint potential outliers. And what I'm going to be finding is a range of values which I would normally expect my data to lie within if it is normal data, right? If it's not something that's very unusual for my data set. Now, just because a point is unusual doesn't mean that you want to discredit it or disregard it. We always have data points that are potentially going to be different from the rest. We have in every population things that are a little bit different from the rest of the population. That's normal. But we don't expect to see more than one in a data set, and we don't expect to see them with great regularity. So we want to pay attention when we see these come up, and if we see more than one, that's a usually a fairly good indicator that we may not have normally distributed data or symmetric data. So what we're going to look at for our above data was that 77.1, that one that I pointed out that was way far away from the rest of the data. We want to see if that is a potential outlier. So we're going to compute this interquartile range. So I'm going to go to the next page.